And our speaker, Sati, is here to provide the essential guidance needed to validate, secure, and monitor your applications as it goes live. Uh, let's welcome. You are welcome with your talk. I can stop sharing my screen and let's dive with workshop and explore RAG, conquering the last mile. And I think I can follow you. I opened another screen waiting for links.
Oh, I'll start sharing.
Okay, and if it's possible, can you share link at the chat?
Sorry, link of what?
Or you haven't link, we need to scan QR code, yes?
I know I have a link which I will put on the chat.
Yes, okay, yes,
But
perfect.
I'm just initially gonna just go through some slides and then I'll share the link.
Okay, perfect. Let's start.
Hi, hello everyone. My name is Sathyaram Sannasi, or also Sati for short. I am a data engineer and I do quite a bit of work with customers on data and obviously on AI related topics. And I'm also a Google developer expert in data cloud. So just as a quick introduction about retrieval-augmented generation, or also known as RAG. So, like LLMs are primarily trained using public data, as you would be aware. Like it is all the data that is available on the internet and other sources that may be used. But if you want to use your own data, or you want to use LLM with your own data, how do you do it? So that is where our RAG comes in. So in RAG, what you do is like you provide the LLM with your data, and then you ask when you prompt the LLM along with your data, then you get the results as if it is coming from your LLMs, like normally what you do. So in this case, let us just assume it is like kind of a chatbot, which is the easiest to understand. It doesn't necessarily have to be a chatbot, but obviously this is the easiest to understand. So let us say the user in number one issues a prompt. When it comes to when I say QA system, it is just basically a chatbot. When it comes to the chatbot, that prompt is passed to the external data stores. External here in the sense external to LLM. So this is our own data, which is stored as vectors in this data store. So based on the prompt, the right records are selected, or the right documents are selected from the data store, from the external data store here, and that is passed back to the chatbot, and the chatbot picks that up, and then along with your query plus your the documents which are selected from the external data store based on your prompt. So your prompt plus the information that comes from the vector store. This is all passed to the LLM, and the LLM interprets all that information and gives back a response. So that is what you see here. So the important thing is like with a RAG is like you create a vector store, and then based on your prompt, the relevant documents are selected, and that is passed on to the LLM, and the LLM provides the result. So this is so when we just talk about this, it's like pretty easy to kind of build this. Like you have like a few commands, I would say. You can build a prototype for a RAG. Like you have your own data, you have your company's data, or whatever. You'll be able to build this, build a RAG prototype very easily. Because as we saw here, it is just you build this data store, and then the data store, and then you can easily connect with it and then generate it. But The hard part is like getting that to production, because like you don't know, you have developed it, but you don't know what the output is, whether it is right, whether it is secure, and all those things. And also, like as you know, like LLMs are non-deterministic, so every time you get different results. So you have to ensure that that LLM understands your prompt correctly, and and gives back. So this is the hard part. It's easy, very very easy to build a basic RAG system, but moving into production is hard. So what makes it hard? So you have to ensure that your retriever, when I say retriever, it is the retriever retrieving data from your internal vector store. Is it getting the relevant information? Basically, is it getting too much information, or is it getting too less information, or is it getting the right amount of information from your vector store? So that is something that you have to assess and ensure it is getting the right amount of information. And again, is the LLM, after you give the prompt to the LLM, is it generating the right response? Is it hallucinating? Does it take all the information and build a complete picture with the available information and your question? And also, is it accurate? You have given it all the information. Is it using that information accurately and giving the right response? So these are the things. These are things. Some of the things that make it hard. And another thing is like, how secure is your RAG system? So if in an enterprise there are a lot of documents, and not every document is supposed to be seen by everybody. So each person will have their own set of documents that they can view. So you have to ensure that the vectors, the documents that you provide into your RAG system, into your RAG database, only the authorized users of that document are able to see. Not everyone should be able to see. And then whether there is personally identifiable information in the document, and this becomes extremely important in Europe with GDPR. So if something goes wrong here, then your company is going to be like fined and have a problem with their reputation and everything. And beyond this, there are also the general security concerns like prompt injection. So what is the user prompting? Are they giving prompts that would actually reveal more than what you are supposed to reveal? Reveal? Is it dumping all the information? Is the prompt making the LLM dump all the information? So this is not a RAG specific one. This is a general LLM concern, like security concern. And again, the same with model and data tampering. So is the model secure? So especially if you are using open source models, let us say, then you have to ensure that the model is not tampered with. And again, data. The data you have put into your vector store, is it right? Is it not tampered? Is someone tampering it? So all these things are also important from a security perspective. And it's not just that. We have to evaluate the data. Is the user getting the right data? So we have provided all the information. Is the user getting the right data? That is something that we have to continuously evaluate in the real world for the RAG system to be effective. And is the quality of the outputs continues as desired? So it is not just about when you implement the RAG system. So over time, you'll be adding more and more documents, more information into the system. And does your systems still work as desired? Is the output quality the same? And again, response times. You want to ensure that your response times are acceptable. You don't want the user to be waiting too long. Again, it depends on system to system. Some applications and some users, based on what we are expecting. Some users and some applications will be happy to wait for a little longer, but not all the time. So it's still, you have to look at whether the response times are acceptable for that particular application and user. So these are the things that make it difficult to move a developed prototype of a RAG application to production. So out of this, one of the most important things is like, how do we know the output is good? So that is something that we need to measure. And I would say, if this workshop, that is the most important takeaway for you. So these are some of the frameworks that are available, and I think most of them. I'm sure Vertex AI is not open source, but Ragas is open source, and yeah, I don't remember about the other ones. But these are the most very common evaluation frameworks that you can use. And Ragas is specifically or very much targeted towards RAG, and that is something. If you are building a RAG system, that is a library that you definitely have to have a look at if it makes sense for you. And there are other ones as well. And Vertex AI, which is the Google's Google Cloud's AI platform. It has an evaluation service where you can run your evaluation on your RAG system and outputs as well, and you can combine that along with RAGas to make it much more effective. So for evaluation, the metrics can be like statistical, or which is deterministic, which is called RU. This basically looks at like you provide an output saying, okay, this is my expectation of the output, and when you're evaluating, you look at the output of the LLM and compare it with what you have provided and see how close they match word for word. And it's not necessarily word for word, it's like a bunch of words and stuff like that. There are various forms of rules. So in this case, if you provide two sets of the expected output and the output from the LLM, if you are providing these two the same, then your output is always going to be the same. So it is deterministic. But not everything can be deterministic. And the model sometimes provides, it depends on your question. Sometimes the model may give the right answer, but it may not be exactly or very close to what sentence you have given. So which means you cannot really just use RUG to say, okay, this is my answer, and this is the answer from LLM, and I want to compare and say, okay, it is not matching word for word, or it's not very closely matching. The meaning may be the same, but it won't match word for word. So in that is where model-based evaluation comes in. So model-based evaluation is basically where you use another LLM model to evaluate the output of the first model. So in this case, you can measure how grounded the output is, and if there's, for example, toxic sentences in the output. So these are the sort of things that you can measure. And these are like two different ways of measuring the output. Not specifically for RAG. This is generally for LLM outputs as well. So in here, like as we saw, like there is the input, which is the prompt, and then you have the retriever, which retrieves the relevant documents from your vector database, and then it goes to the LLM to generate the result, and the output is sent here. So here you can think of it like these two types of metrics: retriever metrics, like contextual accuracy or correctness, and then generated ones is the generated output relevant and faithful. Faithful is groundedness. So this is what we discussed saw in the previous one. So contextual relevance, to say how relevant is the context for the input. When I say context, it is what has been extracted from the vector database. Chunks of the relevant documents have been extracted from the vector database. And then the recall, did it fetch all the relevant information? So there may be a lot of relevant information. Has it fetched all the relevant information or maximum amount of information? And the precision is do the relevant nodes in the context rank higher than the relevant one. So if you have said, okay, you have extracted 10 documents and only 3 or and you have to rank them to understand what to ensure that we get the right results. So after ranking, you just say, okay, is it relevant to the context? And from the generator metric side, it is the answer relevance. So you have provided a query. How relevant is the output for the query? Is it complete? Has it answered all the questions? Has it answered the right questions? Even if it has answered only part of the questions, at least is it all right? So those sort of things have to be kind of checked. And also faithfulness and groundedness. This is extremely important. So the document has been passed to the LLM. Has it hallucinated? Has it just used the information from the documents, or has it made up things? So these are the sort of metrics that we would be evaluating RAG based on. And also I did mention about security. So the security you can think of is like you have to check the prompt, you have to check the output. So all these things have to be done, and there are some frameworks there are some frameworks and libraries that allow you to kind of do it. So not really going too much into this, but just for information, I have provided this slide. So from a RAG perspective, I would say this is the kind of flow. So you for evaluation, what do? You create a test data set. You provide a question, and you know what the answer is supposed to be. So you provide both of that to the evaluation system, and the evaluation and the evaluation system runs an evaluation and creates a baseline to say, okay, so for each of the metrics that we are interested in, how good the current system is, and then you use that information to say, okay, so let me adjust some parameters. So there are various parameters. There may be LLM parameters. There are the model parameters, the embedding parameters. Like when I say embedding, those are the parameters that are useful for creating the vectors to populate the vector database. So parameters for that, and also models, even different models. You may even have to kind of evaluate with different models how good each of the models are. It may be the model for generating the embeddings, or that is basically generating the vectors of your documents, and also model for generating the output. And then you run the evaluation again, like you did in the second step, and then keep adjusting the parameters and run the evaluation. So this is kind of, it's not like you do it once and it is there. So you have to try multiple times with different parameters and then find the most optimal one for your use case. So yeah, I did mention about these parameters here. So the embedding model, so the chunk size. So if you have a large document, before creating vectors, you put them into smaller chunks. So what is the size of each chunk of the document? And then to give some context, you overlap. You don't say first 250 words or characters, whatever. So first 250 words, and then you don't start from 251 to 500. You also have an overlap so that there is kind of understanding. The LLM or the vectors might kind of have an understanding of how these are related. So how much overlap are you expecting? And also, it is not just about these things, also about the algorithms for creating the index. And so there are like IVF, LSH. These are some of the these are common indexing algorithms. And also searching. So what metrics do you use? Do you use cosine distance, Euclidean distance, or there may be other distances as well? So these are very common ones. So based on your use case and uh, what information you need and how your system performs, you use these, and also and how many chunks you want the vector to search and return. So we generated some chunk size, and then now we look at how many chunks that uh, you want the vector you want it to pass to LLM for it to generate the output. And then ranking, I already mentioned about ranking. So from the generated chunks, you rank which chunks are more important, and then you pass n number of chunks, ranked chunks to LLM for it to generate the output. And again, in the parameter tuning, you can use LLM model, you can change the LLM model, you try different LLM models and also different parameters, like, for example, temperature and top N, top E, all this type of stuff. So I have, let me just quickly stop sharing. I don't know how many of you are interested on a Saturday evening to go through this the workshop, but yeah. So if you want $5 credit, use the first link, and the instructions for using the credit, if you have not used it before, is available in the second link, and the Colab notebook that I want to use for this, I will anyway go through it now so that you have an idea of what it is if you want to try later. Yeah, go ahead. Okay, so let me share my screen. So basically, this is the setup. Like you go to this link, then create a new project using a valid billing account. So which is what this one would have provided, and then the link would have provided. Make a note of the project ID, and then open this the Colab notebook and copy it to your drive and start executing one cell at a time. So I just also mentioned some of the things that you might see. The pip in the first step, which installs the libraries, gives some warnings. Just so you can ignore them. And then so in this example, I have used about 5,000 rows in a BigQuery database. So the vector index creation will work, but if you have a small data set, if you are trying on a very small data set, I think it is like 5,000 rows. If the number of rows in your vector database is less than 5,000, then you cannot create the vector index, at least the one which within BigQuery, you can't create a vector index. So it might fail if it's a very small data set. You can just ignore that, because even without that, it will still work. And in the Colab notebook, you will be there will be a step to give authorization for your Google account on the Colab notebook, and also the project and stuff like that. So just select everything. It is your own what do you say? It's your own Google account and your own project. So just select everything, and say, if you're, for some reason, if your session is restarting, crashes, and it is restarting, then I have also marked a number of cells saying run on restart. So just run them in order before you go to the step that you are interested in. You don't have to run everything. So that is assuming you are sitting through in one single sitting. So Colab creates sessions, creates background sessions, and after a particular period of time, it expires. So if you are starting today and then coming back tomorrow to complete it, then you have to run everything. But if it is within a single sitting, you find your session crashes for some reason, then you have to just run on restart cells. Okay, let me just quickly go through. Should I run it or okay? I have. Okay, see here the runtime has disconnected, so it's things times like these. So I have already run this, so I would just go through the code very quickly and also the output. Okay, so here we are installing all the required libraries. And this is what I said, there are a few errors which talks about dependency and the required, the versions are incompatible and stuff. So, but don't have to worry about that. Whatever we are using doesn't really impact. And this cell actually maybe initially you may have to uncomment and run the cell because this basically restarts your session because some of the libraries here, I think PyArrow and LangChain, require a restart of the session for them to work. But when you run it the second time, then you don't second time within the same sitting, then you don't have to restart, or it's better you don't restart. And then here, so let me quickly show you how to create a Google project. There is information in one of the PowerPoint slides I shared, but here you basically create a new project from here. You open your Cloud Console and then click on here and you create a new project. And once the project is created, you will have an ID here. So this is the ID that you need for this workshop. So you just take that and you put that ID here. Remember, it's not your the name you give, the friendly name you give. It is the internal ID that you have to provide. And then just go, this is a data set that you can give any name here. So use and it will be created, so you don't have to worry about is the data set available to me or not. Is the data set already there? You don't have to worry about it. So it will be created, and it's better you don't create it yourself because then you have to make sure you have to create a US Central one. So location, I have used US Central one. That is because all the services there are, as you if you have used the Google Cloud Platform, you would know that not every service is available in every region. So whatever features I have used here is available in US Central one. So I have used, so just don't change the location here. And here, these are additional setups. So once you do it, then you define your embedding model and the LLM that you want to use. So I'm using 2.0 Flash. You can use 2.5 or even totally a different LLM. But of course, then you have to ensure that the parameters and all the information that you pass are relevant there. And this is the embedding model. So here I have used the text embedding model which is available from Google, but there are loads of them, and you can choose, and the information about each of these is provided here and where it is good and all that stuff. So, for example, Hugging Face has this information. So there are a number of these models. Multilingual, or you want only English, you can all filter based on that. So just to show that there are a number of different models for creating the embeddings. And the next step here just ensures your services are enabled. So in this case, it's the AI platform services that I have enabled. So if you are using an existing project, maybe it's already enabled for you, but doesn't really matter. You can just run it. And then here you create a remote connection for that particular location, which will be making use of for creating a remote model. So you are creating a connection here. You don't have to worry too much about this. It's basically you are creating a connection to the cloud resources. from BigQuery to the cloud resources. So that is like a remote connection from BigQuery perspective. And you print out the connection details, and in here I have called the connection as demo connection. And then you get the service account. I think this may be a bit of overkill, but in this case, you get the service account name, because you have to provide some permissions for that. But so I have got the service account name for that connection. So that's what this is, and then I'm providing a permission on the project for the service account. And here I have added a 30-minute sleep time. So basically what happens is, like, when a new account is created, and when you provide permissions and update IAM policies, then it takes a few seconds for it to be propagated. So if you're running your next step immediately, then there is a chance it will fail. So I just said, okay, wait for 30 seconds before you go to the next step. So in this step here, I'm creating the source. Here, basically the source, what I have done is, like, used a Python library to create a bunch of some information about UK funds, like these are mutual funds, the financial instruments. So I created that, and I have shared the data set, so that when you are running this, you don't have to create any new data. So the data is already there. So it has about 5,000 records there. So I make a copy of that to my own data set, or in your case, if you're running this, then it is to the data set that you have defined a few cells above. And then, yeah, creating the table. Then this is where I'm using the connection that I created above to define a model, which will be a remote model, using the embedding model that we have defined. So this is the embedding model that we'll be using to create vectors of your documents. So that's where you create it here. And okay, so now the step 2 is, like, you are building the knowledge base. So I was talking about chunks. So that's where this is, like, you chunk your text and create embeddings, and loads into a new wrap table. Okay, into a new table. I don't want to override the existing table, so I have so I'm defining this as a function. So here we are just getting a rack table name from the call, and then using that table name, and then I'm just creating a temporary table to start with. And this is the definition of the rack table. So basically what it has is, like, from the source, it will have the ID, fund name, ISIN number, but then chunk ID, chunk text, all these are ones which are used, which are embedding related, and also the embedding array. This is also there, and then access level is kind of a string that where we'll populate it with, like, what did I populate? Internal or public. So this is a way where we can kind of do from a security perspective to say, when you're querying, you can add the where clause on the access level to say, based on the user, whether the user is internal or external. You can add a where clause, so that only the relevant documents, only the documents relevant for that particular user is selected. So this is not very specifically embedding related, but this is from a security perspective. This is one way of securing your RAG data. So here, yeah. So you are generating the number of chunks, as I mentioned, like, you are splitting using a text splitter. You are creating a number of chunks, and then populating the temporary table here. So this is the scheme of the temporary table. So this is how we are kind of generating your embeddings. So this is a function that you use to generate your embeddings. And this is the model, and so this is what we defined, created a remote model above, and then this is the input. So this is how you generate the embeddings and store into your data. So here, and now this is where I'm running that function. So I'm passing a baseline rack table name, and then initially I'm starting with the chunk size of 250, and the chunk overlap is 20. So you take the first 250 characters, and then and for the next chunk you start from 231 to 200 to 480 rather than 251 to 500. So you overlap that way to ensure that there is a bit of link between each of the chunks. So once that is created, then you create a vector index on the embeddings so that it is much more efficient to search when you are searching. And this uses a distance type of cosine and the index type of IVF. Okay, so here we are just creating the vector, and I have mentioned here, as I told you already, I mentioned here if you have less than 5,000 rows, an error is returned. So don't worry about it. You can just move to the next step. So so now we have created the vector database with all the information and also the index. So maybe I can just show you very quickly, show you how the table looks. Or the original, maybe I'll start with the original table, how it looks right here. So this is the ID, this is a fund name, again, auto-generated fund name, and this is auto-generated ISIN, which is a unique identifier, and you say the type of the fund, and then you have a description. So this is what we'll be using here. To keep it simple, I just use this. Ideally, you should be using description, strategy, holdings, everything together. So for getting the best results, but I just use description if I remember right. And these are additional information about the fund. And there is creating. So this is the baseline table, which we just populated. Here you have some of that information. So you have the chunk ID, sorry, the fund name and ISIN from the table we just saw. And then this is the first chunk or one of the chunks, and it has an auto-generated ID. This is this chunk ID is more for our understanding if you want to come back and check some certain things. And then, as I mentioned, in this one, it is auto-generated. It says, okay, this particular record can be read only by internal users. And this is the embedding. So this is like a 64 by 64. Oh, this is the embedding. This is the embedding vector. Yeah, and you'll have multiple records like this. Okay, so we have created now the base vector database. So now we have to look at securing the rack pipeline. So here, okay, actually this ask rack system, this is a function we'll be using multiple times. So here we give the name of the table here, of course, then we do the start time so that we can identify how long each of these steps take, and the question embedding. This is important bit. So the question that comes through from the user, you have to create an embedding for that. Only then you can compare against what is stored in the vector database. And also the security filter, we add the security filter here. So that which means based on the user. Ideally, in real life, that's what you'll be doing. Based on the user, you would decide whether it's internal or internal. The user is internal or a public user, and then pass this. But here we have just come up with some random information. Okay. And here we are doing the vector search. This is an important thing. Like we are using the question embedding and comparing against the embedding that is already there in the database. And then we are picking only 3 documents here. And we are saying you want the distance type as cosine. So this is how you extract the information. So you take the results and combine them. So here we are going to be getting 3 documents. So we combine those 3 documents here. So these are 3 chunks from the documents that for each you will get 3. And then you can generate the final answer. Here, that's where you are generating a prompt. So you are giving a prompt, you are providing the context. The context is what we generated from the vector database. And you're also passing the question, the original question that came from the user. And based on that, you get the result. So you pass it to here. You send it to the LLM along with the whole prompt. And yeah, just return this output. So here we are just testing the security feature. So this particular function will be using multiple times below. So here, let us say the test question is, okay, which fund has the lowest expense ratio? And here we are asking the user level as public. So here it would go and fetch, go through the function there, and basically fetch the relevant documents, pass it to the LLM, and give the answer. So here we get the answer for the public user. So this is the one has the lowest expense ratio as per when it is public. And I have also printed the latency, how long it takes for retrieval and how long it takes for generation. And I'm querying as an internal user. So here you pass the access level as internal. So again, you pass that and you get a different answer. The reason is because these are different access levels. So different users are selecting with different access levels, and so you are getting a different answer. Okay. And this is like very basic level of security. So this security is like here when we say internal user, external user, we have just put it inside the vector database itself. In this case, BigQuery is the vector database in this case. So we have put it as part of the data itself. But beyond this, you can use the functionality of the vector database. So in this case, like BigQuery, for example, you can use row-based access control. So whichever user is coming, you have already defined what documents the particular user has access to, what rows the particular user has access to, and only those rows will be picked up. Only those documents will be picked up by the search, by the vector search. So there are various ways of doing it. This is one way of actually telling, okay, which particular document a user has, and which is a very, very basic way. It is not extendable. Obviously, you can have maybe 3 or 4 different access levels. You can't have, and it also becomes cumbersome to use. But this is just as a demo of how we can use it. And not just that. So if you have to check the input and the output, like we saw earlier. So here we are defining the input guardrails. So we are defining some patterns which we think is a sensitive data. So NI number is national insurance number in the UK. I'm not sure, different countries will have their own IDs. So things tax identification numbers or your national ID number. So all those things, these are sensitive data. You don't want that to be exposed, or you don't want the user to provide that information either. uh, and email, phone number, IBAN. You provide these patterns, and also you provide these keywords. Yeah, this may not sound very advanced, but one of the ways you can do is like you can identify the block keywords, and then you are checking the input here. So we'll just go through through executing that function. So here, for example, the question you are asking is, you're first testing a safe query. What are the best growth funds? And then you get the result to say, okay, you're getting the result, and basically you are just identifying based on the previous function. You are identifying whether it is safe because that's what you are interested in this particular step. But if you are providing a national insurance number here, so where we have defined a sensitive pattern. So if in this case it matches that pattern, so it is an unsafe query. So it says, okay, say it's false, and then issues it detected national insurance number 1 instance, and it's the overall one PII. It has detected the national insurance number PII. It has detected. So this is one way of approaching it. So as you would understand, like these things change. There are new features coming in, and so many things change every day. So this take this as a guideline. It's not like this is the best way to implement. I wouldn't say that. This is something that you have to consider when you are implementing the rack system. Doesn't necessarily mean it has to be exactly this. You have to look at the latest advancements and what platform you are using, etc., and what your requirement is. And it's not just the input, even the output, like what the generated LLM generated output. You want to sanitize or you want to check it. So we have defined, that's where we have defined some guardrails here for output. And the example here, we are just testing the output. So let's say the output from the LLM is this: the investor has this national insurance number, and it has also provided a email address, which you don't want. So you can, like a function like this, it's a very basic function here. So it can be sanitized. So the output would just read this rather than giving the actual NI number and the test and the email address it gave. So something like this, this can be done. And as if you remember, like I showed you a few libraries for security, and some of those libraries allow you to do this. Here we have basically created a number of these patterns and stuff. So we don't necessarily have to do this. These patterns are even provided by those libraries. And I would suggest, like if you want to use this as in your RAG development, look through those libraries to understand to best make use of good options. And this is again a bit of security again. So here I'm just checking if it's a safe query. So what are the low cost index funds? That's a safe query. So here it does identify it as safe, output is clean, and no output modifications. But if the user has asked, my email is this, what funds are best, then you say, okay, you don't want to you don't want to give the output. You just say, okay, I have seen an email, so I'm going to block it. So you can do things like this. So here there is a feature which in the Vertex AI, but for some reason it was not working. So I just put that in anyways. Maybe I'll look through it, why it was not working for me when I was trying, and then maybe fix it. But yeah. And then, so this is what we saw now, yeah. So we saw security, now we have to monitor. So when when a query is passed, you want to ensure you log the query, maybe log the output. Logging the output is kind of neither here nor there. You have to ensure that it is acceptable to log the output of your RAG system based on the application. So if it is sensitive, then you don't want to log the output. So, but yeah, but still, in this example, we are just logging the output as well, and also what the predictor, what the answer could be and stuff. So here, and also if you know, like many of the chatbots have how well you like the query, rate the output. So all these things we are kind of storing, and this is the output. And these are the things we are storing, like timestamp, question, answer, what context was used, what user level, and then we are just randomly generating a feedback score. But of course, if you're in real life, you're not going to be doing this. You ask the user to provide. So by having this, you can use this information to evaluate. So the evaluation is what we are going to see next. And so these are the three things that we are evaluating: groundedness, accuracy, and completeness. We already saw what it was during the present when I was showing you the slides. So I'm not going to repeat that now here. So this is my question, and this is the ground truth answer. And then based on that, I am building an evaluation data set. So here I have like 15 questions and 15 answers. And when I run the evaluation, so these are the metrics and how you define it. So you are defining it on a scale of 1 to 5. You want the output in the scale of 1 to 5. And this would be kind of the instruction when you're running it. And yeah, so this is like basically the Vertex AI evaluation service, which is provided by Google, Vertex AI. So here I'm running. So these are additional functions to run the evaluation. So here I have run the evaluation, and maybe we can see here. This is specific for Vertex AI evaluation service, but very similar things you could possibly do in other platforms, or you can build your own evaluation service as well. So here, these are the metrics like accuracy, completeness, groundedness, and all this stuff. And yeah, results. So this is the result. What we see here: number of rows and accuracy, mean and standard deviation of the accuracy we got, completeness we got, and the output. You can look at it. Oh, I forgot the name of the plot. It's called the radar plot. Yeah. So you can look at the radar plot so that it's easy to compare which ones are good, which one is bad, and of course, the greater the area of this triangle, then the better the output. And also here you are looking at in a bar chart perspective, and the mean actually here. Okay, and so now we have built a baseline. So now we want to, earlier we used a chunk size of 250 and overlap of 20. So now I'm using a smaller chunk size of 100 and an overlap of 10. Yeah, ideally I should have used overlap of 20 by following the principle that we have to change only one parameter at a time. But yeah, whatever it is, this is what I've done. So I'm creating the vector index. Now I'm using a different table. So that the whole table is also there. If you want to go and rerun the previous one, you can run. So it is just, I created a new table. And yeah, it will be the same, but the same structure as I showed before, but it's fundamentally the chunk size is different here. So we'll have more records. And here again, we have just built the vector table and the index. And again, we are running running the evaluation again here. And then this step, we are just showing the output here. With a chunk size of 100, the groundedness is better, and the accuracy is also better when compared to the baseline. So I think that's the primary thing. So here you validate, secure, and monitor this. So what I would say is, if you are building a rack system, consider this as a framework. Don't not about the technicalities of each of it, but it's a framework where you have to ensure that your rack system is secure, and your rack system, you're able to monitor it, and the rack system, you're able to validate it. It has to be repeatable. The validation has to be repeatable. That's and you continuously monitor and validate it so that the output of the rack system is acceptable. And yeah, so I have done a very quick thing with the raggers as well, but I have not tested it. So, but that, if you are using this if you are using this notebook, then maybe you can refer here and then go back into raggers documentation and make sure whatever is provided here is right. Yeah, I think that's all for me. Do you have any questions? I know it took a little long time to go through the code. Hope it is useful. But do you have any questions?
So I see in chat we have any questions.